In this video, I'd like to show you how to use some of the more advanced features of JUnit 5. You should have Eclipse, JDK 8, and Maven installed in order to follow along with the video. This video accompanies the IBM developerWorks tutorial JUnit 5 Part 2. In this video, we will clone the code from GitHub for Part 2, tour the code, look at and run a Parameterresolver extension in Eclipse, look at and run Parameterized Tests in Eclipse, and as a bonus, available only in this video, I'll show you how to run the console launcher. And I've included a sample script to run the launcher as well. Let's get started. I'll open a terminal window on my Mac and navigate to a directory on my computer where I want the code to land, and I'll execute the git clone command. Git clone https github.com Makoto Go Hello JUnit 5 Part 2. Once the code has been cloned, I'm ready to import it into Eclipse. Go to File, Import, Maven, Existing Maven Projects, navigate to the directory where you cloned the code, select the project, and click Finish. Let's start with the code under test, the application itself. The application itself uses Spring, so I've created a simple, abstract Spring configuration class that must be implemented in the test harness. The application is very simple since the focus of this tutorial is not on application development, but on JUnit 5. It consists of an entity, person, a data access object interface, person DAO, and a Spring Bean implementation of that interface called person DAO Bean, and that's it. And then there are the test classes. Common code is located in the com.makotojava.learn.junit package, where you'll see classes like person generator, which is used to generate person objects, person test enum, which is used to provide a stock of person objects that are used for testing, and a couple of implementations of the abstract Spring configuration class we saw earlier. Test Spring configuration emptydb creates an empty embedded Apache Derby database. Test Spring configuration also creates an empty Derby database, but adds some test data, which is generated from a method on the person test enum, so that the data in the DB stays in lockstep with the person objects managed by person test enum. The other packages are specific to JUnit 3, JUnit 4, and JUnit 5. Now let's take a deeper look at some of the features of JUnit 5 from the tutorial. Recall from the tutorial that a Parameterresolver is a JUnit Jupiter extension. There are two Parameterresolver implementations with the sample application for the tutorial. The first is generated person Parameterresolver. The supports parameter method returns the result of comparing the parameter type to person.class. If it matches, then it returns true, indicating the type is person. Otherwise, it returns false. The resolve parameter method is called by the test engine if supports parameter returns true, and in that case, it returns a generated person object from the person generator. The second parameter resolver is random existing person parameter resolver. Again, it supports only person objects. And resolve parameter returns a random existing person from the person test enum. Now let's see how to use these parameter resolvers. In the person DAO bean test.whenDatabaseIsPopulated.add method, I use the extendWith annotation to register the generated person parameter resolver. When this test method runs, the parameter resolver will be invoked and resolve parameter will return a new generated person object which will be added to the test DB. In person DAO bean test.whenDatabaseIsPopulated.update, the random existing person parameter resolver is registered again via the extendWith annotation. When this test method runs, the parameter resolver will be invoked and resolve parameter will return an existing person object from the person test enum at random and updated in the database. Now let's see this in action. I'll run the test from within Eclipse. On the person DAO bean test, choose Run as JUnit Test. When it runs, I see the JUnit test report in Eclipse, and I'll expand all so we can see everything. And there is the result of the add test method, and there is the result of the update test method. Parameterized tests are new in JUnit 5. At a high level, a parameterized test consists of a test method which is marked as a parameterized test with the Parameterized Test annotation, and must specify a source of its parameters. There are several types of sources supported by JUnit Jupiter, but I'll only talk about one in this video, value source. This is the simplest type of parameter source to use and allows you to specify an array of select objects, string, int, long, and double, and that's it. Let's look at person DAO bean parameterized test and see how to write one of these. In the nested class person DAO bean test find by ID test method, you can see I've declared an array of longs whose name is longs and consists of 5 elements. Another thing to note about using value source, the name of the array inside the value source annotation must adhere to a strict but simple naming convention. The name is always in all lowercase. If the array consists of longs, the name must be longs. For strings, it's strings, and so on. As you can see in the find all by last name test method, where the array contains strings, the name is strings. The test method will be invoked once for each argument in the array. Now let's see this in action. In Eclipse, I'll right-click on person DAO bean parameterized test and choose Run as JUnit Test. When the test finishes, I'll expand all so we can see everything. Finally, I want to show you how to run the JUnit console launcher. It can be a little tricky to set up, so I've provided a script with the sample application that you can obtain from GitHub. Let's take a quick look at the script. And a quick note, if you clone the code from GitHub, then the script should just run fine right out of the box with no changes. I'll start off by defining some variables. Mainly this is for maintenance purposes. It's just a habit I've gotten into after years of programming. There's the console launcher jar root, which is the path to where the console launcher standalone jar resides. Then there's the launcher jar itself, followed by the path to the various dependent jars, which are specified by the dependent jar class path environment variable. Then there is the path to the classes themselves, including the classes we're testing and their unit tests. Finally, as a convenience, I define a variable that lets you modify the script to exclude certain tags. You can read more about this in the tutorial. To kick off the script, I'll execute this command, /run-console-launcher.sh. When it runs, you get a nice report showing all of the unit tests along with a summary at the end of the run. And there you have it, some of the more advanced features of JUnit 5. If you found your way to this tutorial through some other path in IBM developerWorks, be sure to check out the IBM developerWorks tutorial JUnit 5 Parts 1 and 2. A link to the tutorial series is in the video description below. I hope you enjoyed the video and thanks for watching. I'm Steve Perry and I'll see you next time. So long.